You nick your hand on a dirty tool. Before antibiotics, that tiny cut could kill unless cleaning, drainage, and protection kept infection local. Because the cut is not the real danger. The danger is what enters through it. Your body fights back exactly as it does today. Blood clots, immune cells arrive. Most small injuries still heal. But if microbes multiply inside crushed tissue, around a splinter, or inside a sealed pocket, the wound can worsen. Redness spreads, pus collects, fever begins. If the infection reaches the bloodstream and triggers sepsis, local remedies may no longer be enough. People had tools, observations, and treatments. Some helped, some hurt. None worked like a reliable antibiotic inside the body. The most useful treatment was often the least mysterious. Find what should not be there. Dirt, cloth fibers, wood, metal, and dead tissue can remain inside an injury. Across different times and places, practitioners washed wounds, pulled out foreign objects, cut away damaged tissue, and left heavily contaminated injuries open instead of sealing trouble inside. Today, this family of actions is called source control. Irrigation carries contamination away. Debridement removes tissue that can no longer recover. Neither one is an antibiotic. They change the battlefield so the body has less to fight. Historical records do not tell us how consistently ordinary people received skilled care. A useful principle could exist while many patients still had no access to it. Now imagine the surface closes while infection continues underneath. Pressure rises inside a painful pocket. Medicine painted on top may never reach the center. Opening a route for infected fluid to escape can remove part of the source. Drainage is one of surgery's oldest persistent ideas, but people did not always interpret pus correctly. In influential Greek and later medical traditions, laudable pus was treated as a favorable stage of healing. That belief lasted for centuries, even though pus can also signal an abscess or destructive infection. Some draining wounds really did improve. A practitioner could see the result without understanding microbes, pressure, or dead tissue. Observation found pieces of the mechanism. Theory sometimes explained them badly, and after cleaning or drainage, the wound still needed protection. Egyptian medical records describe wound plasters made with linen or lint, grease, and honey. Each material could do a different job. Fibers absorb fluid and support a dressing. Grease can keep cloth from sticking and form a barrier. Honey is acidic and draws water strongly. Some honeys also produce antimicrobial compounds. Modern research supports real biological effects in some wounds. But this is where an attractive story can become bad advice. Ancient honey was not standardized. Modern wound care uses sterilized medical-grade honey for selected cases, and evidence varies by wound type. A kitchen jar cannot replace professional care, drainage, surgery, or antibiotics. More importantly, a dressing works at the surface. It cannot reliably chase an infection spreading through muscle, bone, or blood. When local treatment failed, medicine became more destructive. Cut away the dead tissue, burn the bleeding surface, remove the limb before the damage climbs higher. Cautery could seal blood vessels and destroy tissue. It could also add a severe burn. Amputation might remove gangrenous or infected tissue, but brought blood loss, shock, contaminated instruments, and another large wound. These were brutal trade-offs. For much of history, there was no anesthesia, blood transfusion, sterile operating room, or dependable systemic drug. One famous battlefield mistake shows how tradition could make the injury worse. In the 1530s, French surgeon Ambroise Paré used boiling oil on gunshot wounds believed to be poisoned. During one campaign, Paré ran out of the oil. He substituted a gentler mixture made from egg yolk, rose oil, and turpentine, then spent the night fearing those soldiers would die. The next morning, according to his later account, patients given the gentler dressing showed less pain, swelling, and fever. Those treated with boiling oil suffered more. Paré abandoned that treatment. This was not a modern trial or an antibiotic cure. Its importance is simpler. Removing a harmful treatment gave the body a better chance. Medicine advanced partly by noticing when accepted treatment made outcomes worse. Still, avoiding boiling oil did not explain why a clean operation could rot afterward. In the 19th century, surgery could succeed technically and still end in infection. Compound fractures, broken bones exposed through the skin were especially dangerous. Joseph Lister, influenced by new ideas about microorganisms, developed an antiseptic system using carbolic acid. His reports, beginning in 1867, described a discipline: clean the wound, manage damaged material, treat instruments and dressings carefully, and protect the injury. Some cases failed. The method evolved. Other surgeons argued over the theory and the details. But the larger change was profound. Infection was no longer an unavoidable fog around surgery. It was a process that careful technique could interrupt. Antisepsis reduced the chance that microbes would take hold. It still could not reliably eliminate every infection after it had spread through the body. That missing weapon arrived in stages. In 1928, Alexander Fleming noticed that a penicillium mold inhibited bacteria around it. The observation did not instantly fill hospitals with medicine. Penicillin was unstable, difficult to purify, and hard to produce in useful quantities. Oxford researchers later demonstrated its therapeutic potential. Wartime laboratories, governments, engineers, and companies turned fragile batches into industrial production. By the mid-1940s, penicillin could reach infections through the body in a way a dressing or blade could not. It transformed the odds against susceptible bacteria. It did not make wound care obsolete. Dirt still needed removal. Abscesses still needed drainage. Dead tissue still needed debridement. Some injuries still required surgery. Antibiotics added a systemic barrier to the local barriers people had been refining for centuries. Put the chain together. Inspect the injury. Wash away contamination. Remove what cannot heal. Let trapped infection drain. Protect the wound from more contamination. And, when available, use antisepsis and antibiotics against microbes themselves. Before antibiotics, the first 5 steps could sometimes keep a local wound local. If infection spread, survival depended on the body, the organism, available skill, and luck. This is historical explanation, not a home treatment guide. A wound that becomes hotter, more painful, swollen, draining, or accompanied by fever needs medical assessment, and possible sepsis is an emergency. What scares you most? Swelling, fever, or the surgeon? The smallest cut became less frightening only when medicine learned to fight both the wound you could see and the infection you could not.